Greenland's ice sheet is collapsing faster than scientists predicted. And what happens next will reshape everything you think you know about coastlines, weather patterns, and geopolitics. Within the next 7 seconds, I'll show you why this distant frozen island is actually the most dangerous place on Earth right now, and the disturbing truth is that nobody's talking about the real consequences. You've been told climate change is this slow, gradual thing happening somewhere far away. Wrong. Greenland is losing ice at a rate that's tripled since the 1990s. And by the end of this video, you'll understand why that melting affects you specifically, whether you live in Miami, Shanghai, or London. Because here's what they don't mention: when they show you footage of calving glaciers and melting ice, the ripple effects are already starting, and they're not what you expect. Picture this. Greenland holds enough frozen water to raise global sea levels by roughly 7 meters. That's 23 feet. Imagine the Statue of Liberty standing knee-deep in ocean. That's not some distant future scenario. Parts of this process have already begun, and the speed is accelerating in ways that have scientists genuinely alarmed. In 2019 alone, Greenland lost 532 billion tons of ice. That's more mass than the entire country of Iceland weighs. And in a moment, you'll see why this specific year was a turning point that changed everything. But sea level rise is actually the least interesting part of this story. The real nightmare hiding in Greenland's melting has to do with something called the Atlantic Meridional Overturning Circulation. If that sounds boring, wait until you hear what it controls. This massive ocean current system, which includes the Gulf Stream, is responsible for keeping Europe warm, regulating rainfall in Africa and South America, and maintaining fish populations that feed hundreds of millions of people. And Greenland's fresh water pouring into the North Atlantic is actively weakening it right now. Here's where it gets wild. The AMOC hasn't been this weak in over 1,000 years. Some models suggest it could collapse entirely within this century, potentially within decades. If that happens, and we'll explore why it might in just a moment, Europe could see temperatures drop by several degrees, even as the rest of the planet warms. Britain could develop a climate closer to Siberia. Meanwhile, tropical regions would become even hotter and drier. Monsoon patterns that billions depend on would shift unpredictably. And this isn't speculation from fringe scientists. This is published research from institutions like the Potsdam Institute for Climate Impact Research and University College London. Now you might be thinking, how does melting ice in Greenland shut down an ocean current thousands of miles away? The mechanism is disturbing in its simplicity. The AMOC works because cold, salty water in the North Atlantic is dense enough to sink, creating a conveyor belt effect that pulls warm water north from the tropics. But when Greenland's ice sheet melts, it dumps enormous volumes of fresh water into the ocean. Fresh water is lighter than salt water, so it sits on top, preventing the normal sinking process. Slow down that sinking, and you weaken the entire circulation system. Weaken it enough, and the whole thing could stall out like a car engine running out of oil. Scientists call this a tipping point, a threshold beyond which the system reorganizes itself into a completely different state. And here's the terrifying part. We don't know exactly where that threshold is. We're essentially conducting a live experiment with the planet's climate engine. And we won't know if we've gone too far until after it's already happened. Some research suggests we may have already crossed preliminary thresholds, that the slowdown we're seeing now is the beginning of a cascade we can't reverse. But wait, because Greenland's melting triggers another feedback loop that almost nobody discusses. When ice melts, it exposes darker land or ocean underneath. Dark surfaces absorb more sunlight than white ice, which reflects it back into space. This means once melting starts, it accelerates itself. More melting creates more dark surface, which absorbs more heat, which causes more melting. It's called the albedo effect, and it's already happening in Greenland at a measurable scale. Satellite data shows that areas of the ice sheet that used to be bright white year-round are now darkening with meltwater pools and exposed rock for months at a time. Now let's talk about what this means for you specifically, because abstract temperature changes don't capture the real impact. If you live within 50 miles of a coast, and roughly 40% of humanity does, You need to pay attention to this next part. Every centimeter of sea level rise doesn't just mean water creeping up beaches. It means storm surges from hurricanes reach farther inland. It means higher high tides flooding streets and overwhelming drainage systems. It means salt water infiltrating freshwater aquifers that cities depend on for drinking water. Miami already experiences sunny day flooding, where streets flood at high tide even when there's no storm. Charleston, South Carolina, has seen a 500% increase in tidal flooding since the 1970s. Cities across Southeast Asia, from Jakarta to Bangkok to Ho Chi Minh City, are watching groundwater turn salty as seawater seeps underground. And all of this is happening with less than 1 foot of sea level rise so far. Greenland alone could eventually contribute 23 feet. But here's the part that should terrify urban planners. We don't get that rise evenly or slowly. Recent studies show that ice loss from Greenland has been happening in sudden, dramatic pulses rather than steady increments. In July 2012, 97% of Greenland's ice sheet surface experienced melting in a single day. That hadn't happened in over a century. These pulse events dump massive volumes of water into the ocean in short time frames, creating temporary but significant sea level spikes. Imagine a coastal city preparing infrastructure for gradual change over decades, then getting hit with a half-meter surge in just a few years because Greenland had an extreme melt season. That's not theoretical. It's the pattern we're already observing. And in a moment, I'll show you the geopolitical scramble that's beginning as nations realize Greenland isn't just a climate victim. It's about to become one of the most strategically valuable territories on the planet. But first, you need to understand the human element, because 56,000 people actually live in Greenland, and their lives are transforming in ways that preview what's coming for the rest of us. Greenland's Inuit communities have inhabited this landscape for thousands of years, reading ice conditions, hunting on sea ice, navigating by traditional knowledge passed down through generations. That knowledge is becoming obsolete. Sea ice forms later and melts earlier, making traditional hunting dangerous or impossible. Permafrost that kept buildings stable is thawing, causing houses to crack and tilt. Coastal erosion is accelerating as protective ice barriers disappear. Entire villages are considering relocation. This isn't some distant abstraction. It's cultural erasure happening in real time, and it's a preview of what hundreds of coastal communities worldwide will face in the coming decades. But while local communities struggle, global powers are circling. As Greenland's ice retreats, it exposes vast deposits of rare earth elements, uranium, zinc, and potentially massive oil and gas reserves. For decades, this wealth was locked under ice. Now, as access improves and demand skyrockets, Greenland has become a geopolitical prize. In 2019, reports emerged that the United States considered purchasing Greenland from Denmark. The strategic logic was sound. Greenland hosts Thule Air Base for missile detection and satellite tracking. It sits astride Arctic shipping routes, becoming navigable for the first time in human history. China has invested heavily in Greenland mining projects, offering to finance infrastructure, alarming Western security officials. Denmark officially controls Greenland, but the island has home rule and growing independence movements. Greenland's government faces a brutal calculus. Mining could bring wealth and independence, but at enormous environmental cost. Accepting investment from global powers brings money and jobs, but potential loss of sovereignty. Climate change is accelerating this crisis by making previously impossible extractive industries suddenly viable. Here's the disturbing irony. The fossil fuel emissions that melted Greenland's ice are now making it easier to extract more fossil fuels from Greenland's exposed ground. The crisis creates the conditions for worsening the crisis. And Greenland, population roughly the same as a small town, is navigating pressures from nations with militaries and economies thousands of times larger. Now let's zoom back out to the global climate system, because Greenland's melting has one more catastrophic dimension that connects to something happening right now in your weather. The jet stream, that river of air high in the atmosphere, that steers weather patterns across the northern hemisphere is behaving strangely. It's become more wavy, more prone to getting stuck in place. That's why you're seeing longer droughts, extended heat waves, and storms that stall over regions for days instead of moving through. The leading theory for why involves the Arctic, including Greenland, warming roughly twice as fast as the global average. This reduces the temperature difference between the Arctic and mid-latitudes. That temperature gradient is what drives the jet stream's speed. Weaken the gradient, and the jet stream slows down and meanders more. When it meanders, weather systems get locked in place. California's mega droughts, Europe's killer heat waves, the flooding that devastated Germany and Belgium, all potentially connected to this jet stream disruption, triggered partly by Greenland's changing climate. So now you're starting to see the real picture. Greenland's melting isn't just about ice and water. It's about ocean currents that regulate global climate. It's about feedback loops that accelerate warming. It's about geopolitical competition for newly accessible resources. It's about weather patterns going haywire thousands of miles away. It's about indigenous cultures losing their ancestral homes. And it's about whether humanity can respond to a crisis that doesn't respect borders or timescales we're comfortable with. Here's what makes this especially challenging. The ice we're losing now results from emissions from decades ago. Even if we stopped all emissions tomorrow, Greenland would continue losing ice for years, possibly centuries. But every additional ton of carbon dioxide makes it worse. We're steering a ship that takes miles to turn while already heading toward the rocks. Some scientists argue we may need dramatic interventions, geoengineering proposals like increasing Earth's reflectivity or direct carbon removal. These ideas are controversial and unproven at scale, but the conversation is happening because conventional emissions reduction may no longer be sufficient alone. Greenland's acceleration is why formerly fringe ideas are entering mainstream scientific discussion. Yet understanding these systems also reveals opportunities. Countries transitioning fastest to renewable energy will dominate the next century's economy. Cities investing in resilient infrastructure now avoid catastrophic costs later. The same scientific knowledge revealing the crisis also shows potential paths through it. Greenland itself might benefit in some ways, revealing moral complexity. A warmer Greenland could support agriculture, reducing dependence on expensive imported food. Ice-free ports could facilitate trade. For Greenlanders, climate change offers painful losses and potential gains simultaneously. That nuance gets lost in global discussions, but matters for understanding local responses to mining, development, and independence. What's certain is Greenland won't stay frozen. The only question is how fast it melts and what we do about it. Conservative estimates suggest several feet of sea level rise from Greenland over coming centuries. More aggressive scenarios suggest many meters within this century if tipping points cascade. The difference depends on choices being made right now in energy policy, international cooperation, and infrastructure investment. Here's the final piece. Every coastal city planning document, insurance actuary, naval strategist, and trade negotiator now factors in Greenland's trajectory. What happens on this remote island is becoming central to where your grandchildren might live, what your phone is made of, and whether European winters remain mild. Greenland has transformed from geographic afterthought into a centerpiece of 21st century geopolitics and climate science. And this is why map perspectives matter. For centuries, Greenland appeared huge on Mercator projections, an artifact of polar distortion. Ironically, now that we understand its actual dimensions, it turns out Greenland is genuinely critical, just not for the reasons anyone expected. The island that mapmakers exaggerated is now as important as those old maps suggested. So when you see news about another calving glacier or Arctic temperature record, understand it's not just about ice. It's about the planetary system reorganizing in response to what we've done. It's about consequences cascading through ocean chemistry, atmospheric circulation, geopolitical competition, and migration patterns. And it's about whether we can respond to a crisis operating on timescales longer than election cycles, but faster than we're comfortable admitting. By the end of this video, I promised you'd see Greenland differently. Not as some frozen wasteland, but as the canary in the coal mine, the early warning system, the tipping point we're watching in real time. What's happening there is coming to coastlines, weather patterns, and political systems everywhere. The question isn't whether Greenland's melting matters. The question is whether we'll act with the urgency it deserves before consequences become irreversible. If you found this deep dive into climate systems and geopolitics valuable, consider subscribing for more content that connects the dots between geography and the forces reshaping our world. Hit that like button if this changed how you see Greenland, and drop a comment answering this question. If you could ask Greenland's government one question about how they're handling climate change and development pressure, what would it be? I read every comment, and your perspectives help shape future videos. The description below has links to the research and data sources behind everything you just heard. Thanks for watching, and I'll see you in the next one.